In this video, I will show you the quickest and simplest way to create a reliable pipeline using Upsolver. Upsolver is a managed service that makes it easy, fast, and safe to move data between source systems and your data warehouse or data lake. Upsolver provides powerful observability features to catch data and schema issues before they create problems downstream. There are two ways we can do this in Upsolver. One is with a no-code GUI, and the other is with SQLake, which allows you to do all of this work using SQL. In this video, I'll show you how to use SQLake to build a data pipeline. We start by creating a connection to S3. A connection to S3 allows us to access data stored in S3 via Upsolver. Connections only store access credentials and can be reused by other pipelines. You'll notice some AWS role information and external ID access controls that we need to have retrieved from Amazon Web Services. If you use another cloud provider, this query and information will differ but are mostly similar. In another video, I'll go through where and how to get this information from AWS. Upsolver makes this easier by providing you with an IAM policy required to grant Upsolver as the trusting entity. You can see it by clicking Settings, then Security Information. The samples S3 bucket we're using is one that Upsolver has various demo datasets for playing around with. The dataset we'll use in the video has example purchases made on an imaginary website. You can click the connection name in the navigation and show the buckets and folders underneath it. It's helpful if you're looking for something specific and don't know the bucket or folder name. Once our connection is created, we need to create a table to store the raw data. This step creates a table in the AWS Glue data catalog. You can choose to define a schema or leave it blank, which tells Upsolver you want it to auto-discover the source schema. In this case, we will let Upsolver figure out the exact makeup of the data for us by reading the underlying files. In more advanced cases, we can specify the column to partition on or a primary key. Upsolver automatically adds an ingestion date so that you can partition by date, even on raw data that lacks a date field. We're missing two critical pieces of information: the file location and a way of moving the data into Upsolver to be processed. We accomplish this by creating an ingestion job. An ingestion job in Upsolver is responsible for moving data from the source into Upsolver for more processing, then writes the results into a staging table in the data lake. This job will continue to run in the background and copy any existing and later on new data from the source location in S3. After starting the job, it typically takes a few minutes for the job to start populating data in the output. You'll need to define the bucket and prefix in the job's location property. That must correspond to the location in S3 where that data is stored. If this location isn't correct, you'll get an error. We can query the staging table now that the job is running. Many times a DevOps or data engineer will create the connections, staging tables, and ingestion jobs to make it easier for other, less technical users to implement their business use case, as you'll see later in a bit. I like to run a select query after creating a table to ensure everything works correctly and the data returns as expected. If you've just started the ingest job, it may take a few minutes for data to populate. I haven't shown you how to run a query yet. Let me show you how to do that. This is Upsolver's web interface. After logging in, you can get there by going to https://www.upsolver.com/SQLake-signup-WP and signing in or creating a new account if you haven't already. At the SQL prompt, we can type in our query. You'll notice that Upsolver gives us nice syntax highlighting and even code completion using the Control plus spacebar. I'll click on Run. This requires that your cursor is on the line of the statement you want to execute. You can also use the keyboard by pressing Control plus Enter. When I clicked on Run, the query was submitted to Upsolver. The results are displayed in a tab at the bottom. Now, we can view the query results and ensure everything is what we expected. I take a quick look to ensure all of the types and column names match up. We'd use a regular select query to peek at the data as we did. We'd often use them for quick discovery or verifying that a table we create with a query works as expected. You aren't limited to querying with Upsolver. You can query them directly from your favorite data lake query engine such as Athena, Redshift, Snowflake, or Starburst. Let's also check the table profile page. First, you see the number of events ingested over time. If there are any dips or spikes, you know to dig deeper. Next, you see the table schema. It shows the column names, data types, top values, and density. A density of less than 100% means the data has null values. The last seen and first seen columns tell us if new columns were added or deleted from the table. At the bottom of the table profile screen, you can see the SQL command that generated this table, which lets you confirm its properties and configuration. Lastly, you can see who owns and is responsible for updating the table. You can dive even deeper by expanding the table in the navigation and inspecting each column. You'll see the column values and their distribution. Even more powerful is that these stats are queryable from the Upsolver information schema tables directly from the UI, CLI, and SDK. Our goal is to move this order data from S3 and into Snowflake. To do this, we must add some things in Upsolver and Snowflake. Let's start with Upsolver. In Upsolver, we need to create a Snowflake connection. We'll use Snowflake's JDBC driver to connect with Upsolver. You'll need to update your URL to correspond with the URL of your Snowflake cluster. In this example, the URL is the AWS US East 1 environment. You'll notice that we need our username and password credentials to access the Snowflake cluster. Next, we need to go to our Snowflake environment to create the target table where Upsolver will insert the results. You'll notice that this table creation matches the table definition in Upsolver, meaning that we're simply loading the source data as is into Snowflake without making any changes to it. In a more advanced use case, we may choose to transform the raw data using Upsolver, for example, to flatten nested fields or mask sensitive information before loading it into Snowflake. We click on Run to execute the query. Back in Upsolver, we need to create a job that moves the data from Upsolver Manage Staging Data Lake into Snowflake. We start by configuring how often to run the job and where to start from. Then, we specify which Snowflake connection to use and where to insert the data in Snowflake. Next, we create a select statement that maps the column names to match both sides. We specify these names in case the column names in each table don't match up. Finally, we add a where clause that Upsolver needs to copy just the data that has changed since the last run of the job. We'll click on Run to start the job. That's it. Very simple. The pipeline is complete and running, and we didn't need to configure a schedule or define a DAG to orchestrate these jobs together. The jobs are running, processing data, and copying it. We can see the fruits of our labor by returning to Snowflake and running a select query. It may take a few minutes for data to start populating in Snowflake. This query will be a sanity check that all of our data is moving correctly and to the right places. As we see, everything is working perfectly for us. This video was a glimpse into how quickly you can build reliable data pipelines using SQL in Upsolver. I invite you to run the code for yourself using SQLake and the template we've created that contains all of the code we covered in this video. You can find more tutorials and videos to help you get started at the link below. If you want to go deeper, please watch the other videos covering more advanced use cases such as making real-time and batch data pipelines. Thanks for watching.